Well, hello, pre-algebra class. Today we're going to look at Chapter 6. I have an example. We have about 6 we'll run through, and hopefully I can get it done in 15 minutes. Our first example here is a quantity added to another quantity. And so our first step is to take off the parentheses. So the 4x squared plus 3x minus 15. How did I get the parentheses off? Well, there's a positive out here multiplied into there. They all stay the same. The next step is I have to distribute this sign technically to each one of these signs. And I look at this as if there's a positive out here, everything stays the same. So I could rewrite it without the parentheses. And I'm going to stack these so that you can see a different method than maybe what you're used to, the linear method, writing it all straight out. So the opposite of 3x minus the opposite of 5x plus 6. And the reason I stacked them is for your benefit. Most students can see the difference here. The larger number, we keep it signed. I have a $15 debt. I pay $6 on it, so I still owe $9. I have $3 to pay on a $5 debt, so I still owe 2x. The x is the unknown value of those dollars. The next step is I have 4 of this type of thing, and I'm taking 3 of the same type of thing out, so I still have 1 of those things left, right? The difference between a 4 and a 3 is a 1. This is technically a 1 out front, x squared. So that's our first example today. And it's a positive because of the value of x being larger here than this. So that's our first example for the day. Our second example is something that you may think is a trick. It's not a trick, and they're not trying to trick you. They're trying to get you to understand the difference between multiplying a number by the opposite. So they're really looking at symbols. And do you understand what these signs really are doing to each other? Now the opposite times all of this is going to be the opposite inside. So the opposite times the opposite is a positive. So this becomes 2y. An opposite times a positive is always going to be opposite. It's an even odd rule. If it is odd number of the symbols here, which you call negative, then it will always be negative. So this changes. Now, if you look at, that's my z, I do a line through it because they look like 2's. The opposite times the opposite is a positive, so in the end we have this 5w. Very simple translation. It's always the opposite of what it looks like here with this out in the front. So hopefully that's clear. Don't let them try to trick you. Don't be afraid of them. They're really straightforward. So let's move forward with a complex problem. 4x minus 3 times the quantity of 5x squared. It's fun to write with the mouse. Minus 6, especially if you're not used to it. Hopefully I get better at this. Minus, close that quantity, minus the quantity of the opposite of 3x squared plus x minus 3. Close that quantity. Here's our expression. We have to simplify the expression, so the first step in the order of operations is multiplication. We cannot sum what's inside the parentheses because these are not like terms. So what we have to do now is actually multiply in here, and I'm going to include the negative sign with it. So it's going to be negative 3 times a positive 5. And first I would write this out front so you don't forget that 4x, because we can't do anything with that yet. So a negative times a positive is going to be my negative. 3 times 5 is 15. And I have to bring the x squared with me. Then a negative times a negative is a positive, and this is 3 times 6 is 18. Now I'm going to shift again down below. I'm going to make a stacked problem so that you can see what I'm actually up to. I'm going to distribute the negative symbol into each one of the pieces of this quantity so that you can see what happens. And remember, when there's a negative out front, they all become their opposite. So opposite times opposite, that's my positive. So this is a 3x squared. Oh, I should have lined them up better, sorry. My next one, and you know, I don't think I can erase without erasing the whole thing, and I'd hate to start over, but these should have been lined up, okay? So I'm gonna do this so that you can see where they go. All right, negative times a positive is a negative, and I have 1x, so I'm gonna put my x out here, and it is a negative x. And the next step is going to be negative times a negative positive, so we're going to do plus 9. So now we can sum these up. 8 and 9 is, it's going to be positive because I have positive here, and I had 27 of these things. I have 15 of these, and this was a positive out here. So I have negative 15, sorry, and 3. So it's like having $15 of debt. I pay 3 on my debt. What do I owe? I'm going to still owe a quantity, and it's going to carry itself, the symbol. So I have like, this is like 15 apples minus 3, add at 3 apples. So I'm in debt 15 apples or $15. I pay 3 on it, therefore I still owe 12 of those things. And then I have 4 of these, take away 1 of those, I still have 3 of these. Now the correct way to write this would be the powers, everything should be in order. So this is the 12x squared. The opposite of that 12x squared plus the 3x plus the 27. So that's just one example of what we're doing in the chapter 6. Moving forward then is going to be our next example, and it is simply taking a number outside and multiplying it into each one of the quantities that are inside, and remembering to follow what the signs are supposed to be. You know, you have to always think through, what are these signs? What are these signs? And you'll get it. You know, it takes a little practice to make yourself remember. So I'm going to do it. We're going to distribute this piece into each one. So our first step here, the opposite of 6y times the opposite of 2y squared. Opposite times opposite is positive, so 6 times 2 is 12. And how many y's do I have? I have 2 here, and I have 1 here, so this makes it cubed when we multiply it. Next step, then, is to multiply this quantity to here. Negative times negative is a positive. 6 times 7 is 42. And how many y's are represented? Here's 1 and there's 1. 1 and 1, we have 2 of them. Now, negative times a positive is a negative. Whoops, jumped up on me. And so we're going to have a negative. 6 times 5 is 30. And we bring the y. Whoops, that's a 30. Sorry, I don't know where I got 50. 30y. So here we go. There's straightforward. It's simple. It's takes a little practice, and you'll get it. I'm confident in it. So let's move forward to a little bit more complex kind of idea. Let's move to, get us a color here. We're going to do a quantity times a quantity. And this is a little bit of a complex quantity, I guess you could say, even though it's not all that big of a quantity. We're going to add that to 3x, and then we're going to subtract 4. There you go. This is just FOIL again. So we're going to take the x here, first step, right? X times this, 2x times 1x is 2x to the, how many of them? Third power. There's 2 plus 1. Remember the rule? When I have an x to the first power, I have to add that second power. That's how we get that third power right there. And the 2 comes with us because it's like 1 times 2. Then the next step here is we're going to take this quantity and multiply it over here to the 3. So, and it's positive. So x times 3x is 3x to the second power because we have 2 of the x's that we're distributing here. Our next step then will be to take the x and multiply it by the -4, which gives us -4x. Okay, that's our first step. We're done with x. Now we have to come back and take the -1 and multiply it by each one of the entities in here. Well, if you remember, 1 times that thing is that thing, right? So 1 times anything is still the thing. In this case, the sign will change. So I have the negative, whoops, let's put it where it belongs. -2x squared. Then I'm going to take and distribute it to the next piece right here. Negative times a positive is a -3x. And then I'm going to do the last one is the 1 times the -4, which is my -4. Put a line through, ignore that. This stays a -4. There's nothing to sum with it. I have, in this case, I have a -4x and a -3x. It's going to become a net bigger negative. I borrowed $4. I borrowed 3 more, so I borrowed 7 total. So I owe somebody that. The next one is the difference here. 3 is larger than 2, so I'm going to end up with a positive. If I have 3 minus 2, I have 1 of these left. And so we represent it as x squared. It technically has a 1 out front, but you really don't need it. And then there's nothing to do with this piece, so we just bring it down and it remains the same as it was above, positive. So that's kind of how you would look at one of these. So then let's move forward and do one more problem. Let's do the quantity. We're going to do another FOIL. 2 quantities plus 8, and then multiplied by the quantity of x plus 3. It's the same thing. We're going to FOIL. So we're going to do our first to the first. There's the f. So this becomes 2x squared. We have 2 x's, so it's squared. Then we're going to take this over to the 3. 2 times 3, it's positive again, so it's 6x. Bring that x with you, don't drop it. So now we're going to move to the next, and we're going to multiply the 8 to the x. So we're going to have plus 8x, and then we're going to move that 8 to the 3. It's positive. 8 times 3 is add the 24. Now you notice I'm stacking them for your sake. You can write them all out, and then you have to look for your things, and it seems like it's a little longer, so I just stack things. There's nothing to add to the 24, so it remains the same. I have 8 of these and 6 of these, so I have 14 of the x's. And then I have 2x squared. So that's basically what we're doing in Chapter 6 is we're learning to use, first we combined like terms, we're distributing and we're using the FOIL method. We're making sure that we follow the distributive property. That's really what Chapter 6 is about. Hey, thanks. Have a great time. Enjoy the math lesson. I hope this helps some.